In this video, we are going to talk about the normal distribution. So first off, in this course, no tables, okay? So you may have used tables to do calculations with the normal distribution in the past. For this course, and I think going forward, you need to be able to use Excel or your calculator to do the calculations. On the Canvas page, there are videos explaining how to use your calculator for a couple of reasonably common calculators. I use Excel pretty much exclusively for these sorts of calculations, so I would hope that you would too. Again, when I was growing up, I had a book of tables. My father, for some reason, gave it back to me a year or two ago. The world's moved on. So Excel, calculator, one to the other, no tables. You'll never be given one of these tables and so on. You need to learn how to use the tools. Okay, so the normal distribution. The normal distribution is symmetric, meaning the left side of the distribution and the right side of the distribution are identical. Unimodal, meaning there's one place where most of the distribution lies. And it's a bell-shaped curve. We've all seen this. The normal distribution is defined by two parameters, the mean, usually written as mu, and the standard deviation, usually written as sigma. So we write this as n of mu comma sigma. The standard normal distribution is n of 0 comma 1. So the mean is 0, the standard deviation is 1. So there's a spreadsheet which you can find on Canvas called normal distribution. And we can look at the normal distribution through this spreadsheet. So this spreadsheet does lots of things. We're just going to look at this first tab. Okay, so this is the spreadsheet normal distribution. Right now we have 0 as our mean, 1 as our standard deviation. We're going to look at an Excel spreadsheet. You'll find this spreadsheet on Canvas. This spreadsheet does a lot of things, but the first tab is all we're really interested in. So the normal distribution. And we want to compare distributions to begin with when we change the mean and standard deviation. So here's our spreadsheet. We've got the mean and standard deviation in the top left corner. Right now we have the mean of 0, standard deviation of 1. So this is our standard normal. You can see it here. We could change the standard deviation to 2. And pretty much nothing changes. You saw that the height of the distribution changed a little bit. But actually what happened was the width of the distribution is very different. Our x values have changed. Still centered at 0, but now it should be a little wider. So if we look here, -8 up to +8, -4 up to +4. So a wider standard deviation makes this wider. It always looks the same, but it makes it wider. Changing the mean changes the center. So now a mean of 2, the center of the distribution is at 2 rather than at 0. Okay, so we can play around with this, and basically it always looks the same, with the caveat that it's in a different place and sometimes has a different height. So I can make the standard deviation be 0.5. And it gets taller. It becomes slightly narrower. Probably would help to see these all on the same picture, see multiple distributions in the same picture. Okay, so the things that change on the chart are the x and y values. The shape is always the same. Okay, so we define the z-score. The z-score of an observation is the number of standard deviations that it falls above or below the mean. So if we take an observation from a distribution, and to be honest, it doesn't need to be a normal distribution, it can be any distribution, we can calculate the z-score as x minus the mean, so that's how far we are from the mean, divided by the standard deviation, so that we can scale that distance from the mean by standard deviations. So effectively, this is the number of standard deviations we are away from the mean. Okay, so an example. The mean score on the SAT is 1500 and the standard deviation is 300 points. So I guess this is the old SAT or the intermediate. The SAT when I was growing up was out of 1600. For a while it was out of 2400. Now it's back out of 1600. So this is the old the middle-aged SAT, so out of 2,400. So mean score is 1,500, standard deviation is 300 points, then a score of 1,200 has a z-score of 1,200 minus 1,500 divided by 300, or minus 1. The z-score of a test score of 1750 is 1750 minus 1,500 divided by 300, or 0.83. So this is something we can always calculate for any observation if we know the mean and the standard deviation. Okay, we can calculate another piece of information about an observation. I call this the percentile. So the percentile of an observation x is the percentage of the distribution below x. This is often in Excel known as the cumulative normal function. So in Excel, we can use one of two functions, norm.dist. So norm.dist is going to tell us the cumulative distribution below x, where the mean is mu, the standard deviation is sigma, and we have to do true for the last parameter. If we do false, we will get the probability density function. But for now, and all we really care about in this course, is we always set this to true. Okay, alternatively, we can do norm.s.dist of the z-score of x, and again, true. Okay, so this is our way to work between any normal distribution and the standard normal distribution. And you will find in Excel that there are generic functions, norm.dist, and there are specific ones for the standard normal. And of course, these two things are the same if we set mu equal to 0, the mean is 0, and the standard deviation is 1. So this is the percentage of the distribution below x. So again, what do we mean by that? What we mean is we take a random observation out of the distribution, then the probability of that being below x is returned by this equation. Okay, so we've got two Excel functions, norm.dist, norm.s.dist. First function works for any normal distribution. The second is only valid if the mean is 0, standard deviation is 1. So you've got to remember which one to use. If in doubt, then the first one always works because you can always put in the mean and the standard deviation. Okay, so we can also work the other way around. Take the observation for a percentile. So say you want to find the observation for which y% of the normal distribution is below x. We can do this with norm.inv or norm.s.inv if the distribution is the standard normal. So norm.inv, we put our probability here, the mean, the standard deviation. So this will tell us what observation is the probability of a random observation being below that, y. Okay, so let's do an example. If the mean score on the SAT is 1,500 and the standard deviation is 300 points, we want to know what percentage of SAT scores will be below 1,200, assuming that it is normally distributed. So we do norm.dist. We have an observation. The observation is 1,200. We want to find a probability or percentile. So observation is 1,200. We put in 1,200. The mean is 1,500. The standard deviation is 300. And we always have true. So norm.dist, 1,200, 1,500, 300, and true. So let's go back to Excel. Equals norm.dist, 1,200, 1,500, 300, true. 15.87%. The score for which 10% of observations are below is norm.inv, we put our probability in, 0.1, comma, mean, 1,500, standard deviation, 300, or 1115.53. So let's just check that. Equals norm.inv of the probability, the mean, 1,500, standard deviation, 1,500, standard deviation, 300, 1,115.53. Okay, so that observation, 1,115.53, if we have a random SAT score. So we have a random person, they take the SAT, we look at their score, there's a 10% chance that their score will be less than 1,115.53. This one up here, this is a percent, right? A random observation of the SAT, this mean, this standard deviation, has a 15.87% chance of being below 1,200. Okay, so we have some practice. Let's have a mean of 5, standard deviation of 2, and we want to know what percentage of the distribution is below 2.5. Okay, 2.5, that's an observation. We want to find a percentage. That's norm.dist. Okay, so we go equals norm.dist, 2.5, 5, 2, true. 10.56%. Okay, 5 is our mean, standard deviation of 2. What percentage is below 2.5? 2.5 is our first parameter, mean, standard deviation, true. That'll tell us the percentage of the distribution, 10.56%. Find the number for which 10% of the distribution is below. So now we've got a percentile, and we wanted to know the observation. Okay, so we are going to use norm.inv of probabilities 10, mean 5, standard deviation 2, 2.44. So the observation for which 10% of the distribution is below is 2.44. Let's write these down. So 2.44. The answer to the previous one was 10.56%. 10.56%. Okay, now we have a mean of 10%, standard deviation of 5%. Find the number for which 5% of the distribution is above. We have to do a little more work because our function gives us the numbers for which 5% or some amount is below. But if 5% of the distribution is above, then 95% of the distribution is below. So we have a mean of 10, standard deviation of 5. So we're going to use inv, norm.inv, .inv of 0.95, comma, 0.1, 0.5, 0.05, sorry. Let me make sure I got my inputs right. Mean is 10%, standard deviation is 5%. So we have norm.inv, 0.95, 0.1, 0.05, and we get 8.1822. So 18.22%. And the trick here is that if it's 5% above, if 5% is above, then 95% is below. What percentage of the distribution is above 7%? So this is an observation. Remember, our function returns the percentage below, so we'll figure out the percentage below first. Equals norm.dist of 0.07, comma, 0.1, comma, 0.05, comma, true. So 27.43% of the distribution is below. The complement is above 72.57. So 72.57%, right? Norm.dist gives us what percentage is below. We want above, so we have to do 1 minus norm.dist. Okay, some more practice. Mean is 8%, standard deviation is 10%. What percentage of the distribution is below 0? Okay, mean 8, standard deviation 10. We're asking below, which is the question that Excel can answer in a straightforward way. So equals norm.dist 0, that's our observation, mean 8%, 0.08, standard deviation 10%, 0.1, comma, true. 21.19%. 21.19%. Find the number for which 24% of the distribution is below. This is norm.inv, and we're looking for below, so that's what we can answer. So equals norm.inv of, what we say, 24%, 0.24, comma 0.08, comma 0.1, 0.0093. 0.93%. Means 1500, standard deviation is 300. Find the number for which 12% of the distribution is above. Okay, so that is, we have a percentile, we need the observation. 12% is above, means 88% below, so that's going to be a norm.inv call. So equals norm.inv of 0.88, comma 1500, comma 300, 1852.5. 1852.5. What percentage of the distribution is below 1450? Okay, we're asking below, which is what norm.dist does. We have an observation. We want to find a percentage. So norm.dist of 1450, comma 1500, comma 300, comma true equals norm.dist of 1450, comma 1500, comma 300, comma true. 43.38%. 43.38%. Okay, quick rule of thumb for normal distributions. Approximately 68% of observations fall within one standard deviation of the mean, 95% of observations fall within 2 standard deviations, and 99.7% of observations fall within 3 standard deviations of the mean. Okay, so we've got a chart in Excel, and we're going to try to verify this rule. Okay, now we're going to have to use norm.s.inv twice, and we've got to think about what values go into that. So let's go to our Excel spreadsheet. We can see here the blue is 1 standard deviation, so about 68% of the distributions in here. 95 is blue and orange, 99.7 is blue, orange, and green. All right, let's just do for 1 standard deviation. I'll let you do the rest. So this is 1 standard deviation from the mean. The probability of being below 1 standard deviation from the mean is norm.s.dist, we'll just use normal distribution, minus 1, comma true. So 15.86 is below 1 standard deviation from the mean. Above 1 standard deviation from the mean, well, if it's above 1 standard deviation, that's 1 minus the probability of being below. So that's 1 minus norm.s.dist of 1, comma true. Ooh, it's symmetric, so it's the same. The probability of being outside of 1 standard deviation is the probability of being below 1 standard deviation or above 1 standard deviation, so that's 31.73. Probability of being within 1 minus the probability of being outside. Now we can do this calculation in a slightly different way. We could ask ourselves, what's the probability of being below 1 standard deviation above the mean? That was, let's just do that, equals norm.dist of, .s.dist, let's use, of 1, comma true. That's too big, right? If we start here, if that's too big, we have to subtract off this probability. So that's norm.s.dist of minus 1, comma true, 68.26. So that gives us the same answer. So I did this in 2 ways. I calculated the probability below negative 1 standard deviation and the probability above positive 1 standard deviation. Probability of being within is 1 minus those 2 probabilities, 68%. Alternatively, I said, what's the probability of being below 1 standard deviation above the mean? But I have to subtract off the probability of being below minus 1 standard deviation above the mean. Again, same answer, 68%. So again, not exactly 68%, but it's close. So rule of thumb is 68% of observations from a normal distribution will be within plus and minus 1 standard deviation from the mean.